Good afternoon. Welcome to the webinar. I hope everyone is logged in, ready to go. We appreciate you taking your time out your day. So just to go through a few housekeeping things, this webinar is being recorded. You'll get a link to this after the event as well, so you can share that with other people in your organisation that this might be beneficial to. It'll also be posted up on YouTube as well. Well, we're going to run for 50 minutes today, and then we'll have 10 minutes of questions at the end. So if you have any questions, feel free to type them in, and we'll address them at the end. Okay. All right. Well, let's get into it. So today we're basically going over the coverage verification products that we have at Vicom, specifically the PCTel ibFlex product. That's been a product that has quite a bit of success in the industry already, especially in the 4G cellular world. But in our region, it's starting to make an impact in the public safety and two-way radio area. So for those who don't know Vicom, we started in 1975. We've been around for quite a long time, and we sell test and measurement equipment. It's not just RF. We do everything from RF stuff through to signal generators, through to fiber testing, network testing, oscilloscopes. About PCTel. If you're from the two-way radio side, you've probably used PCTel products without knowing previously. They're one of the largest OEM manufacturers of antennas. Majority of Motorola's antennas are all manufactured by PCTel. The head office is in Chicago, in the US, in Maryland, New York. And they have multiple offices in the US and as well as in Hong Kong. I'll just briefly introduce myself for those of you who don't know. My name is Mark Waite-Pullen. I've been in the radio industry for about 15 years. I started 15 years ago not knowing what a two-way radio was, and I've worked in a few radio companies and learned on the job. I've done quite a lot of coverage testing and verification. The last 5 years of my two-way radio before I joined Vicom in November was spent doing distributed antenna system design for digital UHF services in buildings. So that was services such as DMR and XDN for commercial clients. And then also we did public safety rebroadcast, so P25. This was kind of large scale projects, so everything up to 60-story skyscrapers through to football stadiums, hospitals. So I've got quite a bit of experience in what's required for coverage verification and model propagation testing as well. So when we look at RF coverage, the questions are, well, what are we looking for? How accurate does it need to be? How often should we do it? Who's going to get the information? Unfortunately, there's no particular right answer for this, depending on which application you're coming from. Your answer is going to be different. So if we're looking at two-way radio, we might be looking at it to look at the signal strength. With the new digital formats, signal strength isn't enough. We need things like bit error rate. We need signal to noise ratio. So for example, if you're out there on a wide area system, signal to noise is going to be important. If you're in a crowded spectrum, you're going to want to see that. If you're in an in-building situation, you obviously want to look at the signal of the system you're rebroadcasting within the building, but you also at the same time want to look at the macro networks that are outside and see how far they're coming in, so your radio is not wobbling between inside and outside coverage. How often should it be done? This changes depending on your requirement. We've had clients who are getting coverage testing every 12 months. Some clients are getting it every 6 months. In the US, PCTel's worked with the FCC to create a standard for the public safety rebroadcast. where building owners have to get a coverage test every 12 months, and that needs to be submitted to verify that the antenna system within the building is still performing, and the public safety agencies can have confidence when they're in that building that they'll have coverage. Who needs this information? Yeah, sometimes it's just for end user confidence. You just want an end user to know, if I go in this back corridor at night, am I going to have radio coverage? If I walk down this trail in this national park, for example, am I going to have mobile phone coverage? So that sort of information will inform how accurate it needs to be. So if it's an end user who's just looking for confidence in signal, well, your accuracy probably needs to be as accurate as your mobile, as your two-way radio would be. So there's no point going out there doing a great rig to look at with a nice big antenna with great gain, elevated, when the person who's going to be receiving the signal is going to have a portable radio strapped to their hip. So in that case, it doesn't need to be as scientific. It just needs to be real world representative. And who needs this information? Sometimes it's radio engineers. So in that case, you're going to want as detailed information as you can get. You're going to want to give it to them in raw data form so they can put it in their own propagation models. Sometimes it's a building owner. In that case, if you give them signal strength and channels and bandwidths, it's going to go over their head. What they need to know is, does my building pass or fail? Simple yes or no. So with the PCTel product, ibFlex specifically, we can cater for all these needs and varieties. So PCTel scanners, there's quite a few, 4 scanners in their range at the moment. Basically, the difference between these scanners are kind of the industries they're aimed at and the power and speed of the measurements, as well as the frequency range it supports. I won't go into these in too in depth, but I'll just give you some examples of how they vary. So the first one is ibFlex. The main thing with ibFlex is it only supports 6 gigahertz down. It does support 5G, but obviously it's only going to be below 6 gigahertz. However, it does have 4 antenna inputs, so we can do 4x4 MIMO measurements. This one's particularly aimed at your cellular industry, hence no support for the public safety radio. And you can look at this measurement rate. We're looking at 24 5G carriers at one time, measuring 30 times per second. So it's quite a powerful device. ibFlex. ibFlex adds the public safety technologies, but it also adds extended frequency range. So now we're looking at millimeter wave. We can get up to 40 gigahertz depending on the model selected. So it's you can see though that the scanning rate of those 5G carriers, the maximum number of channels, it lowered slightly. And the latest one is the G-Flex. The G-Flex, this is 120 5G carriers simultaneously. If you're talking sub 6 gigs, it's doing that 33 times a second, or 25 times a second for the millimeter wave. With millimeter wave here, it is a continuous spectrum, and we can go all the way up to 48 gigahertz. So this, again, this is really for your network engineer level in building DAS market. This one does not support any public safety. Okay, so what we're looking at now is ibFlex, and this is a main product that we've been showing. We've had agencies purchase this product already, and it's kind of does a little bit of everything. So it supports 5G only up to 6 gigahertz, so FR1. It supports all your two-way radio technologies, well, not all of them, but DMR and Tetra. Supports P25. We can do 4G scanning, 2G, GSM, even your your digital train radio system, GSMR, CDMA. Now it has 2 antenna inputs, so it can support MIMO as well. So 2x2 or 4x2. One of the things about ibFlex is it's very small. I'll show you my unit, which I have on my desk behind me for today's demo. Let's see if I just quickly turn my. Sorry, I can't see it because of the background. But it's a very small, compact unit. It's very lightweight to take around. And the main thing with this unit is the amount of carriers we can support at once. So if I speak from two-way radio world, we can support 20 P25 carriers at once. So this is really the advantage of this over some of the traditional coverage testing methods we have available for digital radio. Most of those are only supporting 1 carrier at a time. So if you're walking a 60-story building and you want to look at the in-building system as well as the half a dozen macro sites that the building can see, this saves a heck of a lot of time. The other advantage is mixing other technology types. So at that same time we're doing a P25 walk, we could be walking the 4G and 5G signal strength in the building as well. We can be comparing multiple bands and multiple frequencies. So part of the PCTel range is you obviously have the scanners, which are the physical device collecting the data. Then you have the software which aids in that collection and gives you the graphical representation of it. So the first piece of software we have over here is Seahawk Touch. So Seahawk Touch is Android based. So you can walk around on your tablet or mobile phone, but obviously tablets a better viewing platform. It pairs via Bluetooth to the scanner, so you have no cables hindering you while you're walking around. It gives you simple reports in real time. You can look at KPIs as you're walking around, and it gives you simple playback. When I say simple, what I mean is, while we might be taking samples of multiple channels and multiple technologies, we can only visualize one of those on a map at a time. You'll see when I jump into the demonstration soon what that looks like. The next one above is called Seahawk Collect. This one is PC based, and this is wired to the scanner, either via the Ethernet port or via USB. It gives you the ability to analyze it more in depth. So you can have multiple maps showing multiple bits of information. And it also enables for automated reporting. So that the data that's collected via Seahawk Touch can be imported straight into Seahawk Collect, and then automated reports can be generated. We'll look at that a bit later as well. We also have down the bottom Seahawk Central. So Seahawk Central is a product that PCTel have worked with US agencies and the FCC for managing their building reports. So building plans and designs can be pushed down via Seahawk Central. Technicians can then perform a walk based on those plans, and those reports are uploaded into a cloud platform, which logs all the buildings in the area and their performance reports. So this can be set up so an overarching agency has control of that, and then they can allow certain stakeholders to view those reports. So at any time, a stakeholder agency can look at a particular building at its last report and have a look at what the coverage was like for their particular service. The fourth one is a new product, and this was only announced a couple of weeks ago. So it's still very fresh. We're still waiting on some further details, but it's Seahawk Monitor. So Seahawk Monitor, it's hardware and software. So essentially it's a rack mount ibFlex scanner that can be used on a RF site to do spectrum monitoring and alarming based on certain events. So we can be looking at maybe the noise floor of the site increases suddenly, Maybe you get a interference on a particular frequency at a particular level. So you can schedule alarms to come back to you. One of the interesting use cases for this, though, is uplink testing. This would allow you to do an uplink test simultaneous to your while you're doing a downlink test. This is useful for maybe you have a hidden host site where you have several buildings hanging off this, getting their signal via donor off air. This would allow you to do a walk test of the building that's receiving that signal, and at the same time looking at the strength of the signal that's reported back to the original site. So this is quite a nice way to verify the whole part of in-building rebroadcast, including the original donor site. We will be sending out a recording of this. So yeah, if I jump through any of these slides in the recording, you can just pause them and have a look through them. Okay, so the types of tests that we're supporting with the Seahawk software is we have the indoor tests, which are not GPS based. So this is simply import a floor plan, touch where you are, start recording. When you get to the next location, you touch on the tablet again, and it shows you where you are and populates those readings in between. So one of the advantages of the Seahawk indoor testing is you don't have to spend any time creating the building before you arrive. There are other solutions out there which do some fancy looking maps, but they require hours of work before you arrive at site in drawing the building in 3D and importing the plans. With Seahawk Touch, we can just import a drawing and scale it on the tablet within 10 seconds, and we can get moving. We can even take a photo and scale that photo. So maybe you might turn up to a facility and they have an evacuation plan. Take a photo of the evacuation plan. Then you've got your floor plan to start doing your walk tests. So no prior preparation required. We have your typical outdoor test, which is GPS. As you drive, it's going to log and plot the record the signals that you've asked it to. The speed of this is going to depend on what type of reporting you've asked the unit to do. So if we're talking about signal strength only, we're going to have very high speed, or something like 25,000 channels a second it's capable of. If we're talking about decoding, which is demodulating the signal and having a look at what's inside that signal, we're talking 3 or 4 samples a second, depending on the technology. We'll have a look at that in a moment. So moving at high speeds isn't an issue. The other type is, and this is the one that PCTel have worked closely with the FCC in America. It's a standardized grid test. Now, what grid test does, obviously, it divides the building into grids. And on this, you can see the blue circles. These are actually the points where your measurements were taken. So you would walk to each point, press on the dot, and then it'll take samples for as long as you like. Then you add it to the report, and then it grades that square. The reason why this goes so well in the US is that a report's able to be created right there and then, and simplified for building owners to understand. Lastly, there's an antenna verification. So antenna verification, this is something that DAS contractors might want to use, or even people performing a PMI on an in-building DAS. This allows you to draw all your antennas in the system, tell it what type of antenna it is, tell it what type of gain, where it's located. And then when you're doing your PMI, you simply stand underneath the antenna and record the measurements. Based on the parameters you put in, it'll give you pass or fail on that antenna. So you can see we've got one antenna highlighted yellow here, which has an issue that may need to be looked at. Down here, we're also looking at the average power. So the red line is the average power across the entire system. And then we're seeing the antennas plotted along here of whether they're high or low. Okay. So one of the things with coverage verification is we need to look at the difference between the sampling of the signal and the measurement of the signal. The PCTel scanners are going to be sampling in the nanosecond range. So you're going to have thousands of samples of RF per second, which it then digitizes. Then the measurement rate is how often it plots that on the screen. So each one of those measurements already has thousands of samples in it, if we're looking at RSSI. When we're looking at the measurement rate for the digital technologies, the measurement rate is how many times can I decode all of the information. So for P25, we're looking at maximum 5.4 decodes per second. And that's getting information such as signal to noise, RSSI, bit error rate, network ID, and then what type of modulation, whether it's phase 1, phase 2. One of the things we'll talk about in a minute is frame bit error rate. So you have out of service bit error rate, which is your traditional putting a test pattern through a transmitter. So you might have a P25, you'll log into the base or a DMR, log into the base and get it to transmit a constant test pattern. This gives the scanner the chance to evaluate the bit error rate of that signal as it knows what it should be expecting. That's a very good way to do bit error rate. The downside is it takes the transmitter offline while you do this. And on wide area sites, you might want to do 3 or 4 overlapping sites at the same time. Taking a base out of service on all of them, that might become an issue. You may not even have access to the site. It may just be a network that you're subscribing to. So we use frame bit error rate as an option. So you can get a sample of the bit error rate without taking the service offline. So there's a table of the decode speeds for different measurement types. When we're going DMR, we're getting color code. When we're doing Tetra, we're getting the MNC, which is its carrier number. When we're doing 5G and LTE, we're getting receive power, receive quality, pilot signal. So I'm not a 4G or 5G technician, but a lot of these measurements will make sense to those of you who come from that field. So one of the things with the PCTel that is misunderstood a little bit is that it is very powerful for power measurements. So if you only want to look at the RSSI, so for example, if you're doing a propagation model, there's no point, if you wanted to use this to tune a propagation model, there's no point decoding bit error rate or signal to noise, because that's not part of the model. You're only looking at the power output. And if you're doing that sort of work, you're going to want a lot of samples to give you some confidence in your model. We can take thousands of samples a second. So we're talking on a 12.5 kilohertz radio channel, 25,000 channels simultaneously. Specifically, if you'll see, if we go RSSI on P25, we can look at 2,560 channels with the tablet software, which is more than enough. So any technology that you might have that's not included natively in the PCTel to decode, you can still measure that just by looking at the RSSI. So that might be NXDN for the radio world or some other technology that's not listed here. Okay, one of the things that sets the PCTel product apart is Blindscan. The idea of Blindscan is when we're looking at the cellular carriers, we might be a radio professional who's been asked to evaluate the 4G coverage in a building. Or maybe we're looking at installing cellular boosters, which are becoming quite popular in the industry. Maybe we're doing a larger a micro cell installation. We need to have a look at what coverage is already there from all the carriers. Blindscan allows you to select the band and the technology. So you might select LTE for 4G and band 28 for some of the Australian frequencies. Blindscan will then run in the background and it'll tell you the frequencies that those services are on, the bandwidths. So then it can set up the measurement for you without you knowing which specific channels are active and the bandwidth of those channels. The table I've got up here is just explaining the Blindscan modes. So blind scanning takes time. So the PCTel has a high-speed mode. The idea of the high-speed mode is I can put it in my unit and I can just start walking around and scanning the entire coverage area for what services are there. However, it's not going to pick up really low signals. It's going to favor high signals better than neg 85. We also have a high dynamic range, which is, it's going to be a lot slower. But it's going to pick up signals as low as you specify. We can specify down to 130 dB. So that's the sort of test where you would, maybe you want to look at some donor signals or something. You might stand on a rooftop and you might run the blind scan and stay stationary for a few minutes just to pick up exactly what's going on. And lastly, there's mobile blind scan. Mobile blind scan has been added to allow you to effectively get in your car and drive down the freeway at 100 kilometers an hour and pick up the best serving cells and the channels that are active in that area. You'll see a little bit of blind scan when we do the demo. I just want to touch on the frame bit error rate. So the in-service bit frame bit error rate, we're just looking at a small part of each frame, and that's the frame sync bits at the beginning. So for those of you who are curious as to exactly what part of the frame we're pulling out, that's a P25 example there. All right, what I'm going to do now is I'm just going to switch over to my tablet and I'm going to show you what this actually looks like. So my tablet is running the Seahawk Touch software. Just turn that on. Okay, so you can see I've just got my Android tablet running. I have Seahawk Touch. When I come into Seahawk Touch, the first thing I see is the device list. You can see that I have a ibFlex and I'm paired to it via Bluetooth. If my device isn't there, you just hit detect devices. Let's go here. And then it'll detect any technology, any scanners that you have activated near. So we're going to attach to that scanner and we're going to have a look at the technologies that are available. So these are the way you set up a scan is you'd select the technology you're looking for. Then you'd select the frequency range. So for example, this is going to be LTE. And we might want to do a blind scan of band 28. Now, where I'm located, I have really terrible signal. So it's the levels are going to be quite low. So you can see the next column gives me all my measurement types that are available for that technology and that band. Because I've selected the downlink, the DL, blind scan is available at the bottom. If I select the uplink, these are only the measurements I have. So we're going to look at the downlink side of band 28. We're going to hit blind scan. We're going to select enable. We'll turn on, we'll leave it in high speed. We can also choose if we get all of the layer 3 data with that signal as well. We can also choose our RSSI So since I have bad signal, I'm going to want it to do down to neg 120. Okay. Now I've set that up. I don't need to hit save. Once I get through the end of that, it automatically adds it to my measurements list, which is on this tab here. So if I slide this forward, these are the measurements I have set up in this unit at the moment. I'm going to turn these top two off, delete those. So we're just doing the blind scan. We'll set this as outdoor. I have a GPS antenna just sitting at my window, so the GPS is not going to be as accurate as you would have if you were actually outside. Now, this stage of the software is asking me, which of the tests do you want to visualize and how do you want to visualize that on the tablet? So for me, at this point, I'm doing a blind scan, so it's easy. I've only got one. But I want it to maybe plot the best serving cell or maybe the best received quality. And then it's asking me how I want to label it. Do I want to label it with a cell ID, maybe with the RSSRQ, maybe the RP? Again, this is only for the visualization on the tablet. It's going to be recording all that data anyway. Okay, so I'm going to hit record. Okay, so here it is. It's recording the data and you can already see the channels it's picked up. So down here, we've picked up channel 9410 and 9260. Now, one of those is Telstra and one of those is Optus. As you do this, you'll get used to which channel numbers belong to which carriers. So we can have a tap on that measurement and now we can see all the signals we're picking up, which channel, what the bandwidth of that channel is, and the cell ID. We might want to have a look at this in a table form. So I've got all my green channels, which are Telstra, and I've got all my blue channels, which are Optus. I can look at it as a scan mode or just a summary. So it's not moving all the time. It's just telling me which ones are the better ones at this point in time. How do I know that these are Telstra and Optus? If I look at the data, so this 9263 channel here, I can look at the data and I'm getting all the data blocks from that carrier as well. So in block 1, this is where you're going to find the MNC. So number 2 is in Australia is Optus. So that 926 channel is Optus. That 9410 channel, that's number 1, that's Telstra. Okay, so this has told me what channels I have in the area on that band that I've specified. Where Blindscan is really useful is if I stop this now, it's going to ask me if I want to save it. I don't. I'll delete that. Yes. Now the Blindscan wizard will basically automatically set up my tablet to go and do a full measurement of my Blindscan results. So it's going to say, well, here's your detections. And I detected this channel here 54 times and the other one 53. So I might have 20 channels that appear, but maybe I only see 1, 2 times out of, the 100 scans I did. I can then filter that based on, hey, show me only the ones we saw 54 times. So if I need to get my list smaller, but what we're going to do, we're just going to select them all. So just tick that box and for the entire band and apply. It's taken us back to the measurement screen. Doesn't look like anything's happened, but if we actually look on this measurement tab, you can see it's now set up the proper channel number, the proper bandwidth, ready to go for the measurement. So now this time I can go next, and now I can choose which band I'm plotting on my tablet. So that's one of the other things when we're doing the blind scan, when we're doing a proper measurement, we have access to a spectrum analyzer. So right now I'm plotting these 2 channels and you can see the measurement and the cell IDs. I want to see what it looks like on a spectrum analyzer. So I just hit the little spectrum analyzer icon. and it automatically sets up my spectrum analyzer, which is inbuilt to the tablet, or into the scanner, which is displayed on the tablet. It sets it up for me to see that band. And as you can see, the signal's pretty low. We can also then put markers on that and deltas, and like you would with a traditional spectrum analyzer. You can zoom in and out just with the touch of a finger, change the scale. So it's quite handy to have this if you see some strange readings and you want to verify what the carrier actually looks like. Okay, I'm going to stop this scan. Okay, we're going to go back to our main screen. So these are how you set up your measurements. There's a lot of other, depending on the technology. So if I take P25, we don't have bands as such for the radios. So we have to put a frequency list in. There are two ways to do this. One is I can put a frequency list of uniform, which is start at frequency X, have a 12.5 kilohertz span, and then say how many channels we're going to go up to. So for P25, it's 2,560. So then it's automatically created this channel list for me. That might work in some, if you've got the whole block to yourself, but that's generally not how two-way radio is licensed in Australia. So generally what you want to do is a non-uniform. With non-uniform, you start by adding a frequency, giving it a channel number, and then putting in what that frequency is. A lot of the operators are going to have quite a large list of frequencies for the two-way radio technology. So you can simply import a channel list. So I've got this P25 list here, and the CSV is as simple as channel number followed by frequency. So these are all the channel numbers and the frequencies. If I hit import, it's going to bring them into my channel list. The way I've done this one is I've labeled everything with in the teens is site 1, but 11 is site 1, frequency 1, 12 is site 1, base 2, 13 is site 1, base 3, and etc. So that way I can see which ones. You can save that list. You can save it, name it, whatever you like. You might just do one specific list for one particular RF site with all the channels. You might do your complete eligible control channel pool in this list. And if you know which one is active, then just select it. So if I was going to do P25, I'm selecting decode because I want to get all the P25 information. I simply select the channels I want. Maybe I want all of those. Then the phase, it'll auto detect whether it's phase 1, phase 2. If it's a control channel or a traffic channel. That's just going to affect how it reports. If it's a control channel, if it's not decoding signal, it'll obviously put it down as a high bit error rate and low signal. If it's traffic, it's not going to show a high bit error rate. It's just going to show that the channel wasn't active at that time. Then antenna gain. So you can compensate for the antenna type you're using. Also, while we set it up as well, you can have a look at the spectrum analyzer and have a look at certain channels while you're setting it up. By selecting which type of protocol, which channel. Obviously, I'm inside here. I'm picking up nothing. Okay. So what I will quickly do is I just want to show you some tests. So once we've collected all this data, how can we look at it and analyze it? On the tablet, it's kind of simplified. So I've got a drive test that I've done here. I've got two options. I can play it back, or I can just have a quick view just to get a quick report on a particular parameter. So I'm just going to hit playback. And these are all the services I was looking at in this particular drive test. So this is going to ask me which one do I want to see. So I might say I want this DMR system. You see I've got 5G there. I've got 4G. I've even got the train rail system because I was close to a train station. Okay, I'm going to look at the bit error rate of this DMR channel. So here's my view. The blue is where the route I took while I was driving. So I've got a mix of freeway driving at 110 as well as around residential areas. So I can select down here the speed that I play this back at. So we're going to go 8 times the speed and we're going to hit play. So if I drag this dot up, you can see my table of all the measurements that I'm taking and how quickly they're being plotted and sampled. And on my screen, I'll zoom in. You can see my movements and the bit error rate of that DMR signal being plotted. To the side of the screen, I have my, I guess my index of showing me the signal and the percentage of the signal that falls within that particular range during this drive test. This can be edited at any time within the tablet, so you can set up these to be however you want. And you can edit them per technology, per signal. So you might have one scale for signal to noise ratio, another one for RSSI, one for DMR RSSI as opposed to P25. So it's highly configurable. So this allows you to look back and see what was going on. At any time, I can click on any one of these, let's say these P25 channels here. So I can see the RSSI, the signal to noise ratio. I'm decoding the NAC as well as the bit error rate. Or I can look at them in a table view, which one's the highest, which one's lower, that sort of thing. One of the other things we can look at is just do a quick view. So let's say from that drive test, I want to know what the 5G signal was like. I can now select my 5G. And what I want to see is you can see the amount of items we can look at when we're looking at a 5G signal. I want to know what was the best serving cell ID and what was the beam index of that cell. And I want to label that. Well, I'm not actually going to show a label on this one. You don't have to show a label. If you want to do a report to show a client, sometimes the labels get in the way. So what we're seeing here is I've got nice multicolored dots. If we click on my key over here, we're getting the key. So the best serving cell ID was this light blue one here, 732. And then inside those dots is the beam index. So which beam was serving that particular area. So you can get quite detailed. If you wanted a very simple view of the overall coverage, this is a very simple view where you can take a screenshot and then send that to, maybe it's not for a client. They're not paying for a report as such. They just want to know that there's coverage, or you're verifying the network that you maintain for them. This may be more than enough just to take a screenshot. The other thing I'll just quickly show you, I'm very wary of the time. I don't want to run out of time here. Here is a playback of a spectrum analysis scan. So when we spoke about how fast you can monitor RSSI, so this is the same, a different route, but I'm monitoring 1 megahertz of spectrum at 5 kilohertz intervals. So I'm doing 200 channels. Now, obviously my table doesn't help me much, doesn't look, there's way too many channels, but if I do my bar chart, I'm basically getting a spectrum analyzer representation. I can have my max. So here you can actually, that's a good example right there. You can see the center of this one here in the middle is the control channel. And this one over here is a traffic channel of that same site. It's coming up sometimes and disappearing others, but we can see that the max signals, they're pretty consistent. So that's just to give you an idea of how many channels we can handle at once. So you might have an analog system, a voting system. So the voting system might allow you to, you might want to analyze all 20 of your analog voting channels. We can do that quite easily. What I'll do is I'll show you some indoor testing. So this is an indoor test. So we're going to do playback of this one. This is 2P25 carriers. This is not a real indoor test. It was just simulated. Okay, so I've hit play there. You can see as I do the walk test, my readings being populated. Again, that's nice. All we're doing is tapping where we are. So those markers are my check-in points. If I speed that up a little bit. So now I've changed the signal that I was generating to get some bit error. So you can see my points as we go along. So that's your walk test indoor. Nice, easy to get going. All right, what we might do is I'll just very quickly show you a grid test report. So for this, we're going to go to our device list. One of the things you can do is you can, once you've saved all of these settings, you might want to use them, or you might want to share them with someone else who needs to quickly set up this tablet. If you're doing a lot of carriers, that can take some time. What we can do is we can load a workspace. Says, hey, do I want to get rid of these measurements? The answer is yes. And now I've got different workspaces I've got ready to go. So I'm going to do this one here with no 5G. And if I look at my measurements tab, all the things I want to look at are saved here, ready for me to go again. So if you have a particular building, repeating test is very easy. Once you've done the initial setup, you can go back to site, recall the workspace, and off you go. So we're going to quickly do an indoor. So I'm just going to ask me, what do I want to plot? Now, this is going to be interesting because I'm not going to have much signal at home. Okay. Oh, sorry. We're going to do an indoor grid test, aren't we? All right, so now I've got my choices. I can have a map file that I've already set up and saved, or I could just load and register an image. So I can take any image that I've downloaded to the tablet and then register it. When we register something, that's what I'll do actually. Or you can capture and register an image, which is where you just take a photo with the tablet and use that. So example, where we're talking about the evacuation plans. So I'm going to load and register an image. Maybe it's going to be this. Now, registering it means scaling it. So if it's got a scale written on the drawing, it usually detects that and will do that automatically for you. The other options are register with a ruler, which is what we're going to do, and manual. Manual is putting GPS coordinates down. So even though you're doing an indoor test without GPS, if you know known GPS coordinates, then you can do that indoor test for and get GPS coordinates in your CSV when you export it. So here's an image here. The next thing it's going to ask me to do is to click somewhere on that image and scale it. So I'm going to find a measurement. So this comms room here. I tap on it and then move the other end. According to that drawing, that's 4.9 meters. Click on it again, set my scale. Okay, so my maps, that's all I need to do to get my map. Since this is the grid test report, it's going to want to know, I'm going to give it a name. So I'll just call it test. Then we're going to look at the criteria that we're going to allow to pass. So if we're measuring RSSI, we want to do average or maximum or the first signal. So for each technology, you can choose whether it's average. I quite like average myself, but some people might want max. Depends. Okay, so now I've got my image here. I need to put a grid on it. So I can quickly go and add a grid. It's going to tell me how many columns, how many rows I want. So maybe I want to go 6 by 6. And now I can zoom that grid, place it over my building. Okay. And it's automatically created these grids for me with test locations. Maybe for some reason there's areas I can't test, but we don't want them showing as a fail. So we can delete them. So if we go over here, select delete, I want to delete these ones here from my report for whatever reason. Okay, and maybe when we zoom in on some of these measurements, I can't take this measurement in the middle of the lift shaft here, so I want to move my target. So, okay, that's where I'm going to take my measurement. So once we're ready to go, we actually select the measurement here, and all we do is tap on the circle where we're going to make our measurement. Okay, it's highlighted. And then up here, we press measure. So that's now looking at all of those technology and picking up measurements for all of those. It's now placing those measurements, telling me if it's ready to add to the report and the amount of measurements it's taken of each of those. Again, these measurements are very low because I'm in terrible coverage. Once we're happy with the amount of measurements we've taken, we just hit add to report. Okay, so that is showing me that area has failed. So basically you just replicate that across the report. So we get to our next point, we run the test. Add to report is grayed out because we don't have enough data yet to do it accurately. Okay, now we've got enough data and enough samples. We're going to add that to the report. So that's basically grid test. You can add more floors as you go. Select another floor if you want to add another one. But you can do a building report right from there. So right now, this is showing the number of floors I've tested, the areas I've tested, and its pass rate. And then it's breaking it down into each technology. We can also export that directly to Microsoft Word. So if we hit generate report, it'll generate that in a Microsoft Word document. What I will do is I'll quickly show you what one of those reports looks like. If I go to my files, I go to my indoor grid report. And here's one I've created earlier. And it's got all the details of my device, the serial number, the calibration date even of the unit, very important if you want to do a report that needs to get some sign off. And you can see the results of this particular test. Okay. What I'll do now is I'll just quickly share with you my screens for Seahawk Collect. So Seahawk, we're sort of running out of time here, so I'm just going to show you a very quick example. So Seahawk Collect, I've still got it open from before. Okay, so Seahawk Collect is the PC-based software. So you can have this connected to your scanner and be taking measurements through here like we just did with the tablet, or you can use it for post-processing. So I might be looking at my look at my drives. You can export them from the tablet directly. I actually use a Google Drive to do that. It keeps things nice and easy. This Spectrum drive, I want to play that back. When I play it back, I can choose, I want a map, and one of those maps is going to show me the frequency of that particular one with a label. I want another map, and on this map, I want to see the greatest RSSI, and I want to label that with what the frequency is. Maybe I want to see a bar chart view of that spectrum. And maybe I want a history chart. We can quickly arrange them in a nice pattern. And if we hit play, you'll see the results of my drive test. So I can further analyze these a little bit deeper. We can even look at this as a contour chart or more of a spectrogram style chart. So this is kind of more for more in-depth analysis at an engineering point of view. Another good example of that is if I cancel this playback here. Let's look at this P25 indoor playback. But I might want to do, I can then look at different elements within that reading. So I might want a line chart for my signal to noise, choose which channels I want. Also, I'm going to want the map, maybe a table view, and maybe a table view. Hit play. So I can look at my walk test. And we can see my relationship to signal to noise ratio. So on this one, I had a test set where I was turning a carrier on and off, and you can see the relationship between the signal to noise. The very last thing I'll show real quick on Seahawk Collect is the ability to do reports. So I might open up my Seahawk Collect and I just want to generate a report. I can select the drive test I want to do that report for. So maybe these two. Generally, you'd only be doing one at a time, but maybe you've done 20 floors in one building with the same parameters. You might highlight them all together. So when we go into next, it'll give me the technologies that were on those drives. And I can choose what part of those drives I want over here. So maybe I want my P25 decode for channels 1 and 2. Maybe I want my DMR decode, and then I want bit error rate. And I want that channel. And maybe I want my LTE, and I want the best serving cell for LTE. I can edit my legends for what my scales are going to be. And once we've done that, we can save all of that as a template. So next time, we just load the data, hit generate report, and we're done. So we're going to generate that data now. It's asked me if I want to save this as a template. I do not. So now it's calculating all that data between those two reports and giving me between those two drives and giving me a report. Okay, so what it's done, it's giving me some basic reports. So this is the best serving cell ID for each of those bands. So band 1, band 3, band 28. I get the map. I double click on it and I can see the best serving cell. I also get, on the ones where there's actual measurements, I get a distribution chart of where so the bit error rate was 99% of it, 0.62% was below 2%. And I also get some KPIs, so the minimum, the maximum, and the average across my drives, and the number of samples I've taken. And then last, we can export all these images and save them separately and copy and paste them into our own report, or we could export to document. And when we export it to document, it'll generate a Microsoft Word document, and then it's a template base. So then all that stuff comes in automatically, the scanner ID that we saw before, and the calibration comes in. They are Microsoft Word templates, so you can drop in your own logos. You can change what data gets put in there, but it's just using Microsoft Word template. Okay, I think, look, we're getting right on the hour there. I know this is a bit of general overview of what the product can do. Obviously, for each use case, it's going to be quite different how you run it. Look, at Vicom here, we have a demo unit of this that's fully ready to go. So if anyone's interested and would like to learn more, just reach out to us and we can like come and do a more in-depth with yourself one-on-one, or provide you the unit to try in your own environment. But I think at this point, if there's any questions.
Yeah, Mark, there's a couple of questions, so I will just cover it off quickly. So the first question is, what 4G and 5G bands can we test?
So the way the software works is the way PCTel works is you get the bands licensed. So you license whichever bands you want to run with. However, we generally do it in a package where if you get more than 7 bands, it gives you all the bands. So basically, the short answer is all of the cellular bands, all of the 4G and 5G bands are possible.
Thanks, Mark. Question number 2. How many P25 and DMR channels can you measure simultaneously?
So we're talking 20 of digital radio decodes simultaneously. So that's a mix. So you might have 10 P25 and 10 DMR. So 20 is the max of the digital radio technologies.
Thanks, Mark. That's all the questions.
Okay, great. Is there any more, or there's?
Sorry, Mark, one more has just come through. What mapping GIS servers can you use?
That's a good question. So right now it's all just using OpenStreetMap. I don't know the answer to that. I'll take that one on notice. If we've got the details of who asked that one there, we'll follow up.
Thank you, Mark. Over to you.
Okay, that's it. All right. Well, look, I appreciate you taking your time to let me go through the product with you. As you can see, it's quite in depth. There's a lot of stuff in there. It can be set up to be very simplified for your engineers in the field. So yeah, if you want any more further details, reach out to us at Vicom and we'll be in touch.
What about 5G Blindscan? We had issues.
Okay, 5G Blindscan does work. So that's how I picked up the 5G signals in my drive test the other day. The difference with 5G Blindscan here is you have to select the bandwidth. So the 4G Blindscans, you'll be able to just select the band and that's enough. With the 5G Blindscan, you need to select whether it's 15 megahertz or 30. If I just pop back over to the tablet here.
Just for some clarity, they're saying that the problem was that some carriers were not detected.
Okay. Obviously, I can't give an answer on that specifically, but if you want to let us know which carriers you had the issues with, we can look further into that. So if we're looking at the 5G NR, so with the Blindscan options, you can see on the tablet we have it's 15 kilohertz or 30 kilohertz. But yeah, if you want to send us some information about what you were looking at and what the issue was, we can get some answers for you.
Thanks, Mike. There's actually another one that's come through. Post-survey correction. How could that be done?
It cannot. So while you're doing an indoor test, you can always go backwards with your markers. So if you drop a marker in the wrong location, you can undo it. But once the survey, the data is done, that's it. It's plotted exactly as it was. I know there are other tools out there that allow you to adjust the path you've walked if you want to straighten it up and make it a little prettier. PCTel don't have that ability. It's kind of more, this is actually what was measured as it was on the day.
Just some
yeah, you can.
They're saying if the GPS is incorrect, being put into the indoor map.
So that if the GPS is incorrect being put in?
Yeah.
I'm not sure if you can modify that after. Again, I'll have to take that question on notice.
One more question. Post-processing, can you bin capture data? Can you cut and exclude data from certain geolocations, i.e. under bridges, no interference areas?
So binning is not something that's currently supported. That's something I'm actually going to be talking to PCTel about shortly. But no, binning isn't supported. One thing you can do is you can choose in your reporting mode. If you do normal reporting, it'll report every piece of measurement that it had taken. In the reporting mode here on the screen, we can change that to time sampling. So you can say, I want to do samples at this specific time interval. So that way you can control whether just you get measurements all the time or at specific intervals. But no, binning or excluding areas for the GPS, that's not supported. But you do get CSV export of all the data. So if you wanted to go through the CSV export and then modify data and delete it manually from that, then re-import that, yes, you could do that.
We have another question. IoT is mentioned. Is it also capable of measuring Cat M1?
I don't know the answer to that one. I'm sorry. So we'll get back to you on that one.
All right. That's all the questions, Mark.
Great. Okay, thanks.